How you doing, everybody? Randy Richard in the shop. I should say back in the shop. It's been a long absence. This project, this is the Collet Closer, quick change closer off the Logan Lathe. And we're going to go back to this. You saw me build a new, or repair the bearing for it before. But this tube, I don't know what it's made out of, but it's fairly soft material. And it tends to end up with runout after you use it, and I've straightened it out several times, and it bends right in this area here where it exits. It hits the, or actually probably right in this area really, it hits or engages the nut on the end of the spindle to drive it, and it gets a little bent, and then it has a lot of runout. And well, it vibrates and disengages, and it's a big hazard. So I picked up a piece of chromoly 4140 DOM tubing here, and I'm going to make a new tube for this, and I'm going to also change the design of the stop nut that's on the end here. The stop nut, it's a little too thick for one thing, and it ends up hitting this ring, and that causes other issues of disengagement and stuff, especially when there's runout. So we're going to change the design of that so it can be a little smaller and still adjustable and hit the stop portion when it comes out, but be large enough to clamp, and we're going to make the clamping situation a little different on the threaded part. And I might add 1/4 of an inch of length to this tube because of that, to give us more thread here. We'll take it apart, then we'll take the tube, we're going to put it on my roller stand, and we'll just check the runout on it. We'll check the runout on the tube, and we'll get to making a new one. This is a piece of stock we'll use for making the nut. There we go, it's all apart. So we have the lock nut, the bearing and lever assembly. This is just a guard. This is the cam. The bearing rides in here, and then this is the ramp for pushing out the forks, and they ride up on the edge here when they're tight. So this slides in and out, and this is the part that locks to the shaft. And then there's this piece here that this pin will engage in, which drives everything, and this is how you adjust your collet. You disengage your pin and adjust it to the right appropriate hole for the tightness, and you're ready to go. That's the tube. I marked that because this dimension will be critical of where this gets placed because of the length. This then allows you to have adjustment here on the end, and instead of clamping, you can see where it's been being clamped on the tube itself. You can see that. So this hole was not in the right spot, or originally it was in the spot and they've shortened the tube, or this tube came off of something else. I'm not sure what, but there really needs to be divots for this to be firmly attached. If this isn't tight, or if they get loose, it can slip a little bit. So it's important, but I cannot operate in those holes currently because it's not the right length. We'll place new holes in our new tube, and so you can see this. We got plenty of length to work with. We'll jot down some measurements here. This is set on the balancing stand, which is a nice set of rollers. First off, we're going to start over here. We'll start with it out here. Okay, we're set up here on the roller stand. This is a 1/2 thousandths dial indicator, and we'll start down here and just to see how we look, and we're looking about a 1/2 thousandth right there. And I'll just move it over a little bit and keep doing that. There's a couple little bumps and nicks in there, but about a 1/2 thousandth still. 1/2 thousandth. 1/2 thou. Now I'll move it down to the other end. And we're half there. A couple little things, but 1/2 thou. About a half still. About a half. So, you know, overall, it's pretty doggone good. And if I move it this way, it's within a half or less, about a half. So, I'm pretty happy that the tube is pretty straight. Now we'll go over to the lathe. We'll stick it in the lathe with just the collet, and we'll see what kind of play or run out we have at the other end of the spindle. I've already checked the spindle where the collet sits, and I have just a few tenths, so I'm pretty happy with that, with being the age of the lathe. And then we'll measure the play out here in the end where it comes out of the spindle, and we'll see what we have. What I've done here is I've put a collet in, and I've taken just the tube from the collet closer and put it in through the lathe and screwed it tight to the collet. And I have a dial indicator on here. Now I'll zoom in, you'll see this, but just right off me wiggling it up and down, it's about 20 thousandths almost. So that's the play around this nut that's on the end of the shaft. So we'll turn this down. You'll see that that's at 0, close right there. It's at 0. And as I rotate, I'm holding the shaft, the tube down, and we'll roll up here. It's about showing about. If I hold it down, about 8 thousandths, 10 thousandths there. If I let go of it, it runs around 15 thousandths total run out. So, and then if I pulled it here at 0 and I push it up, it's about 16, 17 thousandths also. That's a lot. That seems to be a lot of play. This is the drive part. Has two dogs that engage a nut on the end of the spindle, and then this pin engages into the collet closer portion. So this is your drive piece that goes on here, and even this has a couple thousandths of play. So there's a lot of motion. You know, that's a 23 if I do that. 23 right there, just pushing up on it. That's a lot of motion there that can happen, and this is where I get this. You know, I'll get this off-center wobble, and it really can be bad. Most of the time it's bad. Sometimes it's not so bad. It all kind of matters where alignment of the closer is. So I have a dilemma. Do I make a new nut on the end here, which I can align to which fits closer to the tube and reduces some of that run out, or do I make a nut that I can actually tighten 3 set screws, let's say, or 4 set screws around, probably 4, and I could then align this when I put this collet closer in, and I can do a run out, put my dial indicator on, and align it to the shaft. But by doing this, by bringing this nut out farther, then I push this whole portion back. This has been heat treated. This has been hardened here, so I'd rather not modify that or have to make a new one. Then my tube, I still have a little bit of room on my tube, a 1/4 inch or so on the nut, and the nut's 1/2 inch thick, so maybe 3/4 of an inch. I could come out some, you know, talking a good 1/2 inch here. I'd have to add and then see where I end up and probably make a new nut for the end. So seeing the large amount of play we have, this is probably what is causing the play and the off-center wobble I get on the closer way out here, which it's quite a bit when you're starting to be 6 inches out. So I'm thinking of making a new nut that extends out a little bit, 1/2 inch or so from here, which should have 4 set screws where I can then adjust this and have it tight to the spindle, and you know, dial indicate it each time I put it in and get the run out of it. As you saw on the roller stand, the balancing wheels, measuring the run out on the shaft is in pretty good shape as far as straightness goes. So can I get this 20 thousandths out by doing that and making this firm in here so it can't move? And then this whole assembly will move out, and if I have enough room, I can come out and maybe just make a new nut that grabs a little different out here. So that's my thoughts, and I don't need to make a new tube yet. So I think that's what's going to be first, is make a new nut for in here that locks on and will center the tube.